Today, we'll be talking about memory, cognition, memory, and its parts. So, simple definition of memory is a system that encodes, stores, and retrieves information. So, if you remember at the beginning of the year when we talked about the different perspectives or approaches, we talked about the cognitive approach, and we talked about how that, it encodes information, it stores information, and it retrieves information. So, over the memory notes, part one and two, that's what we'll be focusing on. So while we're learning about memory every day, psychologists still are unsure exactly what parts of the brain are involved and where it is all stored. So we know, we talked about the brain first semester. We know the hippocampus is where new memories are formed, and we know there are a lot of other locations of memory, right? So if something's extremely emotional, then maybe the amygdala plays a part in the memory. And maybe if it deals with smell, we have the olfactory bulbs. And so we know memories in a lot of different places. So we're still learning about all the specific places where memory can be held. So memory's three basic tasks, right? So according to the information processing model, the human brain takes essentially meaningless information and turns it into meaningful patterns. So it does this through three steps, and these are the three steps we're going to focus on in these notes: encoding, storage, and retrieval. Right, so you see a little diagram at the bottom. So encoding is the input, the things that go into your brain. Storage is where you store it, and then retrieval is the output. So like when you need something like an answer on a test, or you're answering someone's question, that would be retrieval. So the first part, encoding. Encoding is a modification of information to fit the preferred format for the memory system. So in most cases, encoding is automatic and happens without our awareness. Other encoding, however, like these notes, require extra encoding effort called elaboration to make the memory useful. So as we'll see as we go over the different types of encoding, a lot of what you do, you don't even realize you're doing, it just happens naturally. But some things take a little bit of effort, right? So a lot of things you learn in school take effort. That's called elaboration. So the more time we spend learning novel information, the more we remember it. So if you look at this chart, the bottom says how many times they repeated the list on day one. And then so that's at the bottom here. On the left, this is time in minutes it took to relearn that list on day two. So the more time you spent on it the first day, the less time it took to relearn on day two. So if you spent 64, so if you repeated the list 64 times, it only took you, what was it, like 7.5 minutes, 7 minutes to learn it day two. If you only looked over the list 8 times, then it took you 20 minutes on day two, right? So the more you look over something, you know, the more you're going to remember it, right? You're going to encode it a little bit better. And I've talked about this since the beginning of the year, the different studying techniques. And a lot of times, it's all about studying smarter. So if you look over something, and we're going to talk about this unit, but if you look over something numerous times, you're more likely to remember it. So not studying 3 hours before a test isn't what you should be doing. If you look at it 5 to 10 minutes every night, your notes, then because of how many times you looked at it, it's not necessarily the length of time, but how many times you looked it over, you're more likely to remember it in the long term and do better on your test. So we talked about the automatic and effortful processing. So automatic processing, this is unconscious encoding of information. So you do it without even realizing it. And so usually the automatic processing can be broken down into space, time, frequency, and well-learned language. So space, we're talking about where you visualize where things are located on a page. So a lot of times you do this without even realizing it. Uh, let's say you're trying to remember something that you read from the textbook, and you might not be able to to remember exactly what it is, but you're like, oh, I know it's right there. It's on that left-hand side of the page. Time recreates scenes to remember where you put your coat. So a lot of times, if you're trying to find your keys, your coat, or something like that, you try to recreate the scene in your mind. You go over the time period in your mind to remember it. Frequency. This is the fifth time I've heard this today, right? So the more you hear something, the more automatically you remember to do it. And then well-learned language. Register words immediately without having to think about them. So your first language is, or it could be multiple languages, but usually, for most people, it's their first learned language. Is it happens automatically. You don't have to think about the words. Where if you learn a second language afterwards, especially, we talked about the older you get, then you have to think about what those words actually mean. And in effortful processing, this is encoding that requires effort, right? So like maybe learning a second language, doing notes in class, learning algebra, calculus, something like that. So the three different types of encoding, right? So we're exposed to stimuli and encode information. We do it in three ways. The first way is semantic encoding. So encoding of meaning, that's the key word. Semantic literally means meaning, okay? So make sure you know that. So when we talk about semantic encoding, we're talking about the meaning of words. The second thing is acoustic encoding, all right? So the encoding of sound. So especially the sound of words. So think about acoustics. A lot of you guys have heard of that before. And then the third thing is visual encoding, encoding of picture images, right? So this is visual encoding. So encoding levels of processing. So how well do the three different ones work? Well, if you know the meaning of the word, right? Semantics mean meaning, so this is the percentage who recognize the word. You're more likely to recognize the word. Acoustics, so like rhymes with, then you'll more likely, to remember the word that's second. And visual, so let's say it's written in capitals, like you can visualize it, it's less likely. So processing a word by its meaning, semantic encoding produces better recognition of it at a later time. So if you understand what something actually means, then you're going to remember that word later on. That's why we always say put personal meanings to things when you study stuff, because if you can understand something, take ownership of it, you're going to be more likely to remember it. All right, the second part is storage. All right, so storage is the retention of encoding material over time. In terms of storing material, we have three stages of memory. We have sensory memory, working memory, which is also called short-term memory, and then long-term memory. And we're going to do a whole separate set of notes on long-term memory. So some theories on how memory works, and I've talked about this before. So synaptic changes in storage. So one physical change in the brain during memory storage is in the synapse. So memories begin as impulses whizzing through the brain circuits, leaving a semi-permanent trace. So a lot of you guys remember me talking about this before. The more a memory is utilized, the more potential strength that neuron has, and that is called long-term potentiation, which is the neural basis for learning and remembering associations. So like everything this year, I try to keep it as simple as possible. This is like a survey class, so we don't go too much in depth, but just the basics so you can kind of understand what's going on. In the notes, in the further slides, if you see LTP, that's what we're talking about is long-term potentiation. And a lot of you guys might remember we talked about this in the brain or when we talked about consciousness, that semi-permanent trace, because the more you go over something, then maybe that trace gets a little bit stronger. And that's one of the theories on why we dream, right? Is to consolidate those memories, because as you dream it again, those memories, that semi-permanent trace becomes a little bit stronger. So strengthening the long-term potentiation. Research suggests that the best way to help things is to study them and then sleep, right? And that goes along with some of the theories we talked about earlier. And there's been a lot of things out there, like even learning a second language, like listening to the tapes, before you go to bed, because that, one of the reasons we dream, and as you remember it, it gets into your subconscious. So once long-term potentiation has occurred, even passing an electrical current through the brain will not erase well-stored memories. So more recent memories will be wiped out. People who have a concussion and cannot remember what happened just before or after the injury have not had a chance to consolidate their memories to the long term. And so we're going to go over this, more in a second when we talk about short-term memory and long-term memory. So a lot of times, if you've had a concussion or electrical shock, you might not remember what just happened to you. That's because those short-term memories haven't been consolidated, haven't been put into your long-term memory yet. But anything that's in your long-term memory, usually a concussion or like an electrical shock, all those memories should still be there. There's something called flashbulb memory. So that's a vocab word, make sure you know. So this is a clear memory of an emotionally significant moment or event. Typically, people remember exactly where they were when the event happened, what they were doing, and the emotions they felt. And so it depends on, everyone has a different flashbulb memory. So depending on your age, maybe it was JFK's assassination. For me, it was 9/11, right? Usually I talk about this on 9/11, but it's a flashbulb memory for me. I was 19, I was a freshman in college. Um, I can tell you exactly, what I did that day, conversations I had, what I was wearing, right? My gray ISU T-shirt, I think, and sweatpants, which I think I still have, at least the sweatpants. Um, I remember conversations. I remember what I saw on TV. MTV actually played music back then. They did a loop. I still remember some of the songs I heard. And so, that's a flashbulb memory for me, right? I remember that Tuesday in September in 2001. Now, another Tuesday, I got no idea what's going on, but that's a flashbulb memory for me. The opposite of that is amnesia. Amnesia is just the loss of memory. And once again, we'll go into more detail about that as well, and the different types of amnesia. So the third part of the information processing model is retrieval, which is the locating and recovering of information from memory. So while some memories return to us in a split second, others seem to be hidden deeper, and so others are never recovered correctly. And so what this diagram shows is the parts of the brain that encode information, right? So that makes sense of it as it comes in. That same part of the brain tends to light up, all right? So you see this here. Then the same part of the brain tends to light up when you're trying to retrieve it. So when you're trying to remember what's going on, you go to that same part of the brain to retrieve that information. Priming, which is the activation often unconsciously of particular associations in memory. If one sees or hears the word rabbit and then is asked to spell the spoken word hare, one will spell it H-A-R-E because they're thinking of rabbit, so that's the way they're going to spell it. All right, so there's uh, a video. There's a couple good videos online. I'll post at least one of them on the playlist that talks about priming. And if someone reminds me in class, I'll give an example of it. Don't want to give it away in the notes though. So when we retrieve stuff, a lot of times we use context. So context is placing yourself in the context where you experience something. Deja vu is an eerie sense that I've experienced this before. All right, cues from current situations may subconsciously trigger retrieval of an earlier experience. And I argue with students every year that deja vu is not actually real. It's not like the movie. If anyone's seen the movie with like Denzel Washington, a lot of times people say, "Oh, I dreamed this and then it didn't really happen." No, it didn't. What happens is this is the misinformation effect, which we'll go into as well. Is you get two similar memories confused. So a lot of times, what you dream about is what's on your mind. Things you experience, things like that. Well, so you're going to experience things that are familiar to you. It's just probability that something similar to that will happen to you. And so a lot of times those two memories blend together and they become one memory. And so you think, oh, you had deja vu. I dreamed this and it really happened. No, you're bound to dream something similar to what's going to happen in your life because, you dream about people and situations that you know. So real deja vu, it's just, it's French for I've experienced this before, or it's more that eerie sense that I've experienced this before, um, not that you literally have experienced this before. Can't happen. All right, so the last slide for part one. So remember, I have to kind of split these up just for how long it takes to save and stuff like that. So the videos can't be too long. So this is the last slide for part one. So retrieval, we're still talking about retrieval. So we're talking about moods and memory. So state-dependent memory, the tendency to recall experiences better if in the same state as when the event occurred. So we're talking about this, we're talking about state of mind. So an example of this could be, if you're drunk and you lost a piece of jewelry, then have a slightly better chance of remembering it if one were to become drunk. Again, though memory while drunk is never that good. But that's what we're talking about if you're in the same state of mind, you're more, it could trigger those same memories. Now, obviously, I'm not telling you to go do any of these illegal things, but that's just what we're talking about. So that same state of mind. There's what is it called? So there's a movie called like Beer Fest, and they find this like beer Olympics type of thing, and but then they can't find it again. So they do the same thing, like they get drunk and high, and then they can find it again because they're the same state of mind. Once again, not telling you to go do any of that stuff, because usually your memories actually worse when you do it. But that's what we talk about when we talk about state dependent memory.